Hi, welcome back to this week's Science Club. This episode we'll be doing a sort of continuation on air pressure and specifically how it affects water bottles. But anyway, now it is time for our riddle. This week's riddle is from a time before COVID-19 when we still had our lockers. This time you're in VC's main hallway where 100 lockers line the walls. Each night the principal goes to check and make sure every locker is closed so that there will be an orderly start for the next school day. One day, 100 students decide that they want to play a prank. The students line themselves up in the hallway and number themselves from 1 to 100. The first student goes down the hallway, opening every locker as he goes. The second student starts from the second locker and, for every second locker, closes it. The third student starts from the third locker and, for every third locker, closes it if it's open and opens it if it's closed. Student 4 follows by opening every fourth locker if it's closed and closing it if it's open. The cycle goes on until student 100 finally goes to the 100th locker. When the principal arrives in the morning, which lockers does he find open? Make sure you pay attention to all the factors and good luck. To do this experiment, we'll need some ice, a 2-liter plastic bottle, half a cup of boiling hot water, cold water, and a small plastic bin. Our first step is going to be taking our frozen ice, opening the bag, and then carefully dumping it into the plastic bin as a bed for our water bottle. Once that's done, we can set it aside for the time being. Next, we're going to take our half a cup of boiling hot water and unwrap the plastic that we put on top to help seal some of the heat in. You can see there's half a cup measured there. Next we'll unscrew the cap from our bottle before carefully pouring the water in since it is boiling after all. Once that's done, we'll screw the lid back on tight. And then let it sit for 2 minutes. Now that the bottle has rested for 2 minutes, we can return to our setup. We'll take our plastic bin with the ice acting as a bed and rest our plastic bottle, which is now filled with hot air on top. Then we take our cold water and pour it all over the top of our bottle like so. The combination of the ice and the cold water mean the temperature of the air in the bottle is dropping rapidly. You can see the shape immediately changing as the outside pressure pushes in. As time goes on, the bottle crushes more and more, especially the sides touching the ice. Turning it over so that each side is exposed to the ice means that we get a uniform crushing all across the bottle. At this point, you could probably predict that all the air inside the bottle has become cold. The pressure of the air inside the bottle pushing out is completely overpowered by the pressure outside pushing in. And that is why the bottle is crushed. And there we have it. The focus of this experiment was the atmosphere and the pressure it creates. Pressure is the force pushing down on an area or surface. Air pressure is the weight of a column of air pushing down on an area. Normally, air pressure doesn't crush objects on the Earth's surface because the molecules in air push evenly in all directions, up, down, sideways, and diagonally. For example, the air pushing out of our bodies is equal to the air pushing in. In the experiment, we see what happens when you take away air's ability to push evenly in all directions. Before we added boiling water to the bottle was filled with room temperature air. Once the hot air was placed in the bottle, the air inside heated up. Once we put the cap back on, we trapped the now hot air inside the bottle. When we placed the bottle on ice and poured cold water on top of it, the air inside rapidly cooled down. Cool air exerts less pressure than hot air. Therefore, the air pressure inside the bottle began to rapidly decrease. The air pressure inside the bottle decreased to a point where it was less than the air pressure outside the bottle. As a result, the air pressure pushing in was greater than the air pressure pushing out, and the bottle was crushed. I hope you enjoyed this week's Science Club. This wouldn't have been possible without Marek Obajtek, our founder, and Richard He, our editor. Once again, if you could fill out the Google form in the description below to give feedback or criticism, that would be greatly appreciated. Also, don't forget to leave your answer to the riddle in the comment section below. Thanks for watching, and we'll see you next time.